And we're going to move on to the next part of this segment, a different aspect of sourcing. And it's a concept for Washington grading using native tree species here in Washington. And I'd like to welcome up to the stage Todd Beyreuther, who is the Senior Director of Advanced Building Materials at Katerra. So welcome, Todd.
Well, greetings. Thank you. First of all, I'm honored to follow Russ and Derek, and I've been honored to be part of this group from its origin, the origin story 5 or 6 years ago, when I was with WSU. It really has been one of the more, kind of gratifying and kind of sense of pride with what we've accomplished together in the state of Washington. A quick little story. I am, here representing my current company, Katerra, but all these other strong partners. A lot of this work has been done as a coalition, and recently was at a awesome workshop. I saw Dr. Lane earlier today, put on by Quorum at UW a few weeks ago, and we had a great presentation by an East Coast architect. And then I got up and was presenting some of these collective ideas about standardization in Washington, and the quick response was, well, that's what Katerra is doing. And it threw me. I have to say, I said, no, this is what we're doing. This is something that we almost take for granted, that we have this diversity of expertise and our focus on our region, our state. So I'm going to go in through a quick, moving from the landscape scale. I'm going to shift to kind of the how, the technical and the techno-economics of this, of how we can utilize these species and make a very specific proposal for the state of Washington. Okay, so let's start with species. Derek and others presented a little bit about this. It was mentioned a few times today. One of our opportunities, but also our challenges in the U.S. and in the Pacific Northwest, is our diversity of species. This is really evident when we go to Europe. We have a group, a lab in Graz, Austria, where CLT was really developed. That's along with other industry and academic partners over there. They have one species. They're starting to branch into other species as we get into Scandinavia and so forth. But really, European spruce is the baseline. Here, we have 4 or 5 primary species around our area that we're focused on collectively developing. And so I'm gonna present this as the 4-state region. A lot of this work comes from biofuels research and development, public-private research and development, WSU and UW, and where we looked at supply chains, and it really takes a capital approach of we have the natural capital, we have the physical capital, the infrastructure, rail, road, mills, so forth. Of course, I agree with Russ's argument that's an area of focus, and that's what this presentation is about. And we have the human capital. We have the ability to span the entire spectrum from the forest all the way to a lot of this audience in the architecture, engineering, and construction world. The 5 black dots there represent then the economic capital. These are recent investments by mills, by, of course, a few CLT, or 2 CLT facilities now. And so what we're really talking about, and there could be other dots on there, of course, Smart Lamb in Western Montana, and when we get into Oregon, we could talk about, D.R. Johnson and so forth. But a focus on the inland Northwest, looking across where these species exist, Douglas fir, Western hemlock, lodgepole pine, grand fir, and ponderosa, and you'll notice that these are, tied. I think it's important we represent this. I really love the work of DNR and bringing us to the 4-digit and 10-digit watersheds. I think this is a great way for us to kind of ground our strategy. So the question is then how? How do you accommodate all those different species? We heard earlier from the AEC side that's a challenge. When I started my career as a structural engineer in Seattle, these were early days for SIPS panels, or SIPS. And there were 3 manufacturers, and there's no standardization across it, and you had to pick a catalog day one and say, I'm going with that manufacturer, and trying to understand and carry it through the project. The shift to a different manufacturer would have been impossible. So let's get down to the LAMSTOCK size and talk a little bit about the standardization. In the U.S., Erica mentioned it earlier, we do have a standardization based on what's available. 2x6 primarily, lumber, dimensional lumber. And be very specific here. By definition, lumber means something that is used in an axial or bending application, joist, studs, so forth. So I use the term LAMSTOCK, and Russ has publicly scolded me many times to be careful about using that term, but I think it demands a little bit of definition, that we use our terminology correctly. So in the lumber industry, LAMSTOCK is a grade, and I hope that's what you mean by that, Russ. If you're speaking to a mill, of course, that's a grade that has a certain market for glulam, so forth, and a 20-30% premium, whatever it might be. But it's specifically for laminating stock, and that's what we're talking about here. We need to lay up this material in perpendicular layups, and there doesn't exist a grade for CLT LAMSTOCK. So we use lumber, and that's available, and there are 1-by and 5/4 markets. And these are the final sizes in metric. So we have this available to us, but in terms of an actual commodity, it's a 2x6 for the most part for us. In Europe, a mill might have 90 different SKUs, to go to different products, to furniture, to so forth. And so Europe's a good lesson for us to look at. Over the last 20 years, they also started with many different sizes. I heard a comment earlier, that is a good thing. We have niche projects where it makes sense at the engineering and architecture level to try to optimize, create custom layups and so forth. But they in the last 5 years are now leading towards a standardization on 20, 30, and 40 millimeters. And so you look at that, why, when the mills can make anything, why does it make sense that 30 is now the new baseline in Europe? So let's just take that as a proposal to start here, that we are making a proposal that if we're going to create right-sized mills that are focused on creating LAMSTOCK primarily, not necessarily feeding into the commodity lumber market, it's not exclusive, but let's just take that approach. Then we start to look at, in addition to thickness, starting out with a standard 6-inch size, but also then making widths that are appropriate for glulam manufacturing. And the architects and engineers in the room, of course, know that as we look at charring rates and so forth, especially as we get into the 2-hour typologies, the sizes can get very big quickly, 12, 14, 18 inches wide. So looking at that, here's the way we do it in the US. So we have a standard, a product standard, PRG 320, and of course we have many champions in the room that have helped develop that, create that standard. But we've also done ourselves a little bit of a disservice, in my opinion, in the sense that that standard was developed 10, 15 years ago, primarily out of Canadian need and support to find a market for beetle kill. So it definitely was proposed under the strategy, find new markets for lumber. And so in that, we've created a little bit of unintentional bias by saying the basic layups are going to be 2x6s. And if you're going to do something different, it's called custom. So in that, the way we qualify is by species first. We might have 2 or 3 different sizes that we could put together in different combinations. We could have 3 or 4 or more different grades, a visual number 2, a visual number 3, mechanically graded, so forth, so forth. And then we have, typically 3, 5, 7, 9. So when you start to play that out, it's upwards of 240 if you really wanted to provide all those different layups. And the qualification process can be very costly and restrictive for manufacturers. The proposal that is looked at primarily in Europe is to standardize on a few different mechanical grades of LAMSTOCK that correlate to 3 standard mechanical properties of CLT. And in this case, I'm taking one step further and saying one size. Let's start and focus one size and start to expand that out over time. But in that, what we're saying is, if we have the ability to mechanically grade this LAMSTOCK, now we qualify into those mechanical grades by species, by mill. We're lowering that bar so that a lumber mill, a LAMSTOCK mill, could qualify into the standardized process. So with that, it shifts the optimization, and structural engineers hate this, and I am an engineer, because it takes away their tool of laying up and optimizing at the material scale. It doesn't eliminate that. We're always going to do that, of course. But if we're talking about creating, if this is 10 or 20% of the projects are niche, big, institutional, so forth type projects, 12-story, so forth, that's different than being able to drive down into affordable housing and provide a competitive material that will now compete in cost with light frame wood. So in that, it doesn't take away the need to pull the moment of inertia lever, is essentially what I'm saying, or the material lever, but we're now doing it at the assembly scale and allowing for different combinations of these 3 and 5 in ply. And this is what it looks like. We still can use this in traditional CLT with gypcrete applications, or we can start to look at now more complex assemblies of components. And where this goes, it also now creates the opportunity as we get more and more modular with CLT to deal with that condition of two boxes, two volumetric boxes coming together, either in terms of double floors or double walls or so forth, which there are also other acoustic and vibration and benefits to that. Okay, so let's go to the markets and say where and how are we going to apply this? What is the need? A great study sponsored by Forterra, also building off of other WSU work, was a few years ago to look at the markets in the Pacific Northwest, those 4 states. And this is focused on multifamily. So 0 to 3 stories, 4 and 5, I broke this up as relevant to the new building types. So we can see we obviously do a lot of low-rise, a lot of single family, a lot of duplexes, so forth. There's a need for that 3-story garden buildings. But we're focused on those new typologies, those 4 to 8-story primarily for CLT. We're in a great position in Washington. Obviously, the codes were talked about earlier, but it's not just the structural, the building code. We have a target, a reach energy code. Like California, our code is put out to advance the industry. We have a state mandate to reach certain energy efficiency and carbon goals by 2030, so forth. And this is part of that mandate to implement an advanced energy code and structural code. So the proposal here is that we're very used to doing type 5A construction, 1-hour fire ratings, up to 5, 6 stories, 5 stories over 1, right? Podium projects, so forth. The proposal would be, let's develop the 6 to 8, the 12-story typology, so forth, and then as appropriate, as competitive, drive those assemblies down into more and more of our low-rise. If we're going to develop the automatic transmission, let's see how many buildings we can push, how many vehicles we can push that down to replace the standard. So this is discussed earlier, but obviously we're in the position with our Washington, Oregon, now Utah, Denver, so forth. But this also now, with this model, this eases alternative means and methods in other jurisdictions. So this is what I already referenced with the building code and the energy code. Okay, so now I'm going to just touch on this because this was a really valuable work that was done by Inder Nail in the back from Ganguli from UW with Forterra, with Heartland and WSU. These were models we developed a few years ago for diffusion. These are available from download from Forterra. What we're saying here is we're trying to look at the assembly scale on market diffusion. So we have to establish a model that is based on risk. And there are 2 main risk categories: risk of code and jurisdiction adoption, and risk of design and engineering, meaning is it a heavier lift if we have to go alternative means and methods, if we have complex timber and composites at 30 feet or so forth. And then the third factor is cost. If we can't be cost competitive, we're gonna slow down, decelerate that market diffusion. Okay, so what you're simply looking at here is what displacement in in a given competitive area, could we displace, whether it's a certain floor type, so forth. Okay, but this is more important. So when we look at applying that now to our needs in the Pacific Northwest, we look at how many square feet, 13 million square feet of low-rise building we need to build in the next, annually, over the next 20 years. Same here. This is that greater than 4, that 4 to 12 category right here. And then we look at our ability to actually move that into the market. It'll take 20 years before we're reaching that saturation. So now as a manufacturer, we pay obviously close attention to that. If our capacity is right here, we've got to figure a way to pull these over and fill those factories, right? That's one way to look at it. But the other way to look at it is to try to use this to make strategic decisions about the specification of the wood. So this is really a proposal to architects and engineers that hold the power of specification to now drive a standardization into the market. Okay, so let's quickly say, well, does it work? These are our span tables, a little sensitivity analysis as an example of different material properties, stiffnesses on this side, and different thicknesses. And the comparison is, should we have even layups or should we have uneven layups? There are a lot of advantages to make those flanges bigger on the extreme fiber, right? That's the kind of general sense. But when we start to look at complex vibration models, we start to see the pattern here. A typical thick 5-ply, just follow the white down. You can manipulate the material lever or you can manipulate the sectional model. And the recommendation is there is an optimization at a thin 5-ply for these low-rise models for 1 hour fire ratings. There is an optimization at a 6 or 7-ply if you were to standardize on that 30 millimeters. So another important performance factor is in plane. So as we start to use this in shear walls, so forth, are we really competitive, and do we really understand, the probabilistic performance of that wall? So we did some screening tests along with WSU about a year or so ago, and this to correlate or to test against a European model that's been developed to say thin lambs have a higher shear stress capacity versus a thick lamb. And so these are our test results, the plus and the X, versus the power curve based off of 20, 30, and 40 millimeters. So I'm going to conclude with what? So lumber mills understand how to do optimization. I don't need to tell them how to cut a circle into rectangles. But if we drive, but where it is cut actually does affect the performance and where we put that in CLT. So this is the common ground. We need to bring these two things together to understand what that specification. And the key takeaway here is that in order for a mill on a to cut to a custom specification, we can commit to that entire center, that cant of that log if necessary, and utilize that fiber only and allow other markets to exist on the edge fiber. I won't get into that too deeply right now, but it doesn't exclude, obviously, mills participating with current 2-by capacity and being able to have additional recovery options for those products. And then ultimately, this is the takeaway, is that we have a few different levers. It's not just the cost of the fiber, it's also minimizing that the call rate, the amount that we throw away. So while you might be able to buy a lower value product, your actual cost will get driven way up if you throw away half of it. So paying for quality fiber, adding more value to that, and having lower call rates is really the takeaway. So with that, thank you.